Hello, in this video, I will solve a couple of questions related to Maclaurin series. Let's see. Question exercise number 1. Write out the first 4 terms of Maclaurin series of the function f of x if these informations are given. Value of the function at 0, of course at 0, because Maclaurin series is the power series centered at 0. Value of the function at 0 is 9, first derivative is 4, second is also 4, and the third is 42. Okay, that means this question is just testing if we understand the formula. I can write a general formula for the Maclaurin series, summation, n derivative at the center, I will put 0, n factorial, and x minus 0, which I will not write minus 0, to the power of n. Okay? So we remember we did derive this formula, nth derivative over n factorial x to the power of n. That means it's important to understand that part. Whenever we have x taken to the power of n, the coefficient corresponds to the nth derivative, the same degree, the same derivative. Okay? Let's expand this. If n is 0, of course, we have just the value of the function. Then we have value of the first derivative at 0 over 1 factorial x to the power of 1. Second derivative at 0, 2 factorial x to the power of 2. And then third derivative at 0, 3 factorial x cubed, and so on. Okay, but we can see I actually write out the first 4 terms. I can keep going. That means I will really recommend that we will all write this down. First derivative 1 factorial x to the power of 1. Second derivative 2 factorial x squared. Third derivative 3 factorial x cubed. So we can see that cube corresponds to the third derivative, in case if we have to find out. Okay, and let's just write this down. That means our function, we have the coefficient. Value of the function for 0 is given 9. Value of the first derivative is 4. 4 divided by 1 factorial, it will stay 4. And then value of the second derivative at 0 is 4, but we will divide by 2 factorial. And value of the third derivative at 0 is 42. We will divide by 3 factorial. Actually, I can say 6. And this one, 2 factorial is 2. 1 factorial is 1. But we have to remember about this extra coefficient. Right? That means this looks like the first 4 terms of the Maclaurin series. And we do have the rest of them, but it's not given for us. 4x plus 2x squared and plus, I think, 7x cubed. Okay, that's the 4 terms of the Maclaurin series because everything was provided. Okay, now let's look at the exercise backwards. Suppose that t sub 5 is centered at 4 for the function f of x and is given here. That means this is the Taylor's polynomial, 5th degree. 2 plus 3, x minus 4, 7, x minus 4 squared, plus 5, x minus 4 cubed, and minus 1, x minus 4, 5, to the power of 5. Okay, now we have to find out what is the value of the first derivative of the function. We don't have this function, we only have this approximation. Third derivative, fourth derivative, and the fifth derivative. Okay, so now we will go backwards. I can just write down the general form. Value of the function at 4, because that's the center. Value of the first derivative at 4, 1 factorial, x minus 4 to the power of 1. Value of the second derivative, 2 factorial, x minus 4 to the power of 2. Value of the third derivative at 4, 3 factorial, x minus 4 cubed, value of the fourth derivative at 4, 4 factorial, x minus 4 to the power of 4, so many 4s. Value of the fifth derivative at 4, 5 factorial, x minus 4 to the power of 5. And please believe me, it's not waste of time writing this and even saying aloud like I did. Please do this okay, after this video. Okay, and now we can match. What we can do. Let's see, we can, okay, I will save my writing. This value, yes, it corresponds to this. That's we are not asked, but if we will be asked what is the value of the function at 4, is 2. Okay, let's take different color. Now, that coefficient, of course, positive 3, because it's a coefficient of x minus 4 to the power of 1, corresponds to this. So let's take this. Maybe write this. First derivative at 4 over 1 factorial equals to 3. We can easily solve for the first derivative at 4. It is 3. Nice. Now we need, okay, let's just do what we are asked to do. Let's take the third derivative. Third derivative will be part of the coefficient next to the x minus 4 to the power of 3. That means this is the coefficient. This is cube. That means 5. This is the same. Third derivative at 4 over 3 factorial equals to 5. Then third derivative at 4, 3 times 6, 30. Excellent. And we have to do the, I'm running out of the colors. The fourth derivative, actually, fourth derivative is no there. That means fourth derivative over 4 factorial is 0. We do not have this. We do not have this term with the power of 4. It means this is actually 0. It's not there, 0. Then the fourth derivative at 4 is 0. Okay, and one more. I'm running out of colors. Let's say this one. The fifth derivative is included in the coefficient next to the x minus 4 to the power of 5, and it's negative 1. That means the fifth derivative at 4 over 5 factorial equals to negative 1. Then the fifth derivative at 4, negative 1 times 5 factorial. I think 5 factorial is 120. Okay, beautiful question. Okay, and let's do one more similar idea. Find the fourth derivative at 0 for the function cosine of x to the power of 4. Even for, I think I saw like 10th derivative or 100 derivative, but let's do 4. We can do even one. I think I have, I did solve it. Okay, but the point is not just take this derivative, because we will end up with some product rule and too complicated. We will rewrite, that means this is the moment to rewrite function cosine of x to the power of 4 using the Maclaurin series, Maclaurin like polynomial. Because it's centered at 0, that's the reason that I said Maclaurin. Okay, that means cosine. Let's maybe start with cosine, then we will be not confused, and then we will put cosine. We will put x to the power of 4. Summation from 0 to infinity, negative 1 to the n, x, quantity x taken to the power of 2n, all over 2n factorial. And when we expand this, when n is 0, everything is 1. When n is 1, 2 times 1 is 2, we will have squared, and we will have 2 factorial, and then x to the power of 4 over 4 factorial, x to the power of 6 over 6 factorial, and so on. And I will recommend to write this down. Now, cosine of x to the power of 4, we will just, let's have it, negative 1. Instead of x, we will put 2n. We will put x to the power of 4. Okay, that means x to the power of 4, x to the power of 4. Then let me do here. Okay, negative 1 to the n. It will be x to the power of 8n. over 2n factorial. And let's maybe expand this. We can even expand this way, as we will put squared 2 factorial to the power of 4 factorial, quantity x, but it's not x, to the power of 6 factorial, and so on. And our quantity, our inner value is x to the power of 4. And let's see what's happened. This is 1, because if n is 0, and then this will be x to the power of 8. Yeah, we can just multiply 4 times the values. X to the power of 8 2 factorial, x to the power of 16 over 4 factorial, x to the power of 24 over 6 factorial. Yes, I'm just looking. Do you know what? Let's just change for 8. Okay, let's just change for 8, the 8th derivative. It will be more fun because you notice the 4th, we do not have x to the power of 4. That's mean let's find the 8th derivative. Okay, okay, that's mean now the derivative. Actually, we can try to find the 4th derivative at 0. We can try to find the 8th derivative at 0. Okay? We can actually do both. We don't have to change because I want, okay, let's keep it 4, but I will also add 8, just in case. Or the 16th derivative, even more fun. Okay? Nobody will try to differentiate 16 times function cosine of x to the power of 4. Okay, that's now how we can recover this information. We know the general formula. Yes, for the Maclaurin or Taylor series. Value of the function at 0, value of the first derivative at 0 over 1 factorial x, value of the second derivative at 0, 2 factorial, value of the third derivative at 0, 3 factorial, oh, I kept x squared, x cubed, and so on. Right? That means I will maybe not write everything because we have to read 1624. But what we know that coefficient of corresponding powers includes the corresponding derivative. Okay? That's when we have x to the power of 8, x to the power of 8, x to the power of 8, that coefficient negative 1 over 2, because I can remove this, 2 factorial is 2, it means negative 1/2, okay? I can write this, negative 1/2, this is the coefficient of x to the power of 8. And the general coefficient of x to the power of 8 will be the 8th derivative at 0 over 8 factorial. Yeah, that means this is the point. And we can see this second derivative 2 factorial, third derivative 3 factorial. Okay, and now we can compute, we can cross multiply, we will have the 8th derivative. How can I say 8th derivative at 0 will be negative 8 factorial over 2, and we can leave it because 8 factorial is a big number. Now we can simplify a bit, but we don't have to. Negative 8 factorial over 2. Okay, so we can see that's the way. Now if we would like to find out we do not have, like the question is asking for the 4th derivative. We do not have x to the power of 4. Then we know that this will be 0. This will be 0. So this is 0. And this one is negative 8 factorial over 2. Okay, I will put negative. Okay, and just in case, if we have to, let's maybe do one more. If we have to find out the 16th derivative, 16th, we can see we have 1 4 factorial. That means this is the coefficient 1 over 4 factorial. This coefficient 1 over 4 factorial corresponds to the 16th derivative at 0 over 16 factorial. Okay, we know the general formula. Because it's x to the power of 16. I can maybe do this. And if we will cross multiply 16, what we will have? We will have 16 factorial divided by 4 factorial, and we can leave it that form. We don't have to use the calculator. Okay? So please, maybe we don't even need this general form, but that was good practice. This general form is messing me because the powers are too high. So we didn't even reach. Okay. I hope now you will be more confident, but please make sure that you know all of the formulas that we have to know and you know the general form. Okay, the general form, which the general form is, that's for instance the 5th degree. Okay, the 5th degree. Take your time and write this down. Okay, and I think I have another question, but I solve it. Find the 10th derivative for this function. And you can see I did the same thing. I write down the x. I did put x to the power of 5. I simplify, and then I know that the coefficient of x to the power of 10, which is negative 1/2, corresponds to the 10th derivative at 0 over 10 factorial. And it is. Okay, enjoy your Maclaurin and Taylor series. Thank you.